Sometimes the thing that we're looking to do is messy. We're trying to find x, and it's not nice and tidy off to one side like it should be. It's all over the place, and we gotta fix it. So we do that. If we look at some examples here, I think the best thing to do is to just dive right in. First, we have to simplify, find like terms, combine them, like we did in polynomials. Then work our way through to isolating that x. Let's try here. Here we have 3 times x plus 6 is equal to 2 times 3 minus x. All right. We could have a lot of different steps to go through this. We could there's a lot of paths to victory. But let's do it by the method that we know best, which is to distribute, collect like terms, simplify. So 3 times x and 3 times 6. 3 times x is 3x, plus 3 times 6 is 18. On the right-hand side, we've got 2 times 3 and 2 times negative x. So 2 times 3 is 6, and 2 times negative x is negative 2x. Already looking better. And then we've already got x terms like those ones, and we've got constants, which are the other ones, these guys. So we'll combine them. I'm going to have a choice. Do I want to combine my x's over there, or do I want to combine my x's over there? I mean, they've got to join one team or the other. I'm going to pick the team that already has positive values, because if I pick the team that has negative values and I bring a positive one over here, I'm going to get negative 5x, and I'm going to have to flip it back to positive later. But by just choosing to move over here, that's going to be nicer. So I'm going to move that over there. I'm going to do that by adding 2x to here and adding 2x to there. These guys are going to cancel out. At the same time, so I'm just going to show 3x plus 2x is 5x before I forget. At the same time, I might as well move my constants out of the way. So take that 18 and get rid of it. 18 minus 18, that's nothing. And 6 minus 18, well, 6 minus 18 is going to be negative 12. So now I'm at 5x is equal to negative 12. Really, really close here. All I have to do is divide by 5, so that I can cancel that 5 out and be left with x is equal to negative 12 over 5, which, I mean, you could write it as 2 2/5, negative 2 2/5, or as negative 12 over 5. Doesn't matter. Whichever one feels best to you, I suppose. I like this always. Let's do another one. Here we've got a minus 8 over 4 equals 3a minus 6 over 6. Let's do something to it. A minus 8 over 4 equals 3a minus 6 over 6. Well, we could go a over 4 minus 8 over 4 is equal to 3a over 6 minus 6 over 6. I could separate all of my top terms into individual whole terms by just remembering that the denominator applies to both parts on the top. The reason I'm not going to do that is because I've just watched a million people, not you, but other people, make mistakes doing that over and over and over. So instead, we'll try to get rid of these denominators first. How can I get rid of this 4? I can multiply by 4 up here. Okay, that sounds good. I can cancel it out. What do I have to do? Playing along at home, you know. I have to multiply this side by 4 as well. Well, I really have to multiply the whole thing, but hang on a minute, we'll deal with that. Now I want to get rid of this 6. I don't like denominators is the thing. I want to get rid of this 6. How do I get rid of that? Well, I can multiply by 6, right? And if I multiply the top by 6, the bottom cancels out, as long as I do the whole top. That's what these brackets were for. And if I multiply by 6 over there, on the right-hand side, I've got to multiply by 6 over here as well. I'm going to rewrite what we've got. I've got 6 times a minus 8 on the left. And I'm going to move that 4 to that side just for aesthetics purpose. 4 times 3a minus 6 on the right. I forget if I called this left or right, but you know your lefts and your rights probably. Now I still have a bunch to do. I still have to distribute. I still have to move things around, tidy up, find my like terms, all that good stuff. So I'm going to distribute here. I'm going to take 6 times a, that's 6a. 6 times negative 8, that's negative 48. On the right side, I'm going to take 4 times 3a, that's 12a. And 4 times negative 6, that's negative 24. Now, I think you know what to do. I've got an a term over there and an a term over there. And I've got a constant there and a constant there. I can combine like terms. So I will. For the like terms, I've got 12 a's on the right and 6 a's on the left. I'm going to go over to, and this is a terrible way to say it, but the winning team, the team that's got more a's on it, is going to have them more positive. I'm going to do that by taking 6 a's away from that side, and the same to this side. 6a minus 6a is nothing. 12a minus 6a is 6a. And for my constants, I'm going to move them. I don't care if the answer is positive or negative. I care that it's away from my precious variable here, a. So I'm going to move over that way. Negative 24. Well, I'll add 24 to get rid of it. So I'll add 24 over here as well. And if we have negative 48 plus 24, that's negative 24. So now we're at negative 24 equals 6a. So close, right? So close. All I have to do is get that a alone by dividing by 6 on each side. That 6 cancels out, which was my whole plan. And negative 24 over 6 is negative 4. So sometimes these are really messy, but it's okay. We can get there in the end. I'll do one more before I was already going to go to bed. I'm going to go to bed soon. So here we got 3x over 5 minus a half is equal to 4x over 2 plus 1. I was lying. I'm never going to bed. We got different kinds of issues going on here. We got different sorts of terms, some that are not in the denominator, some that are. First thing I'm going to do is the easiest thing to do, which is take a constant and another constant, pick a side to throw them to, and throw them over there. At this point, it's really a guess as to whether they should go to the right or to the left, but it doesn't matter. I'll just pick a side. I'm going to throw them on the left, all the constants on the left, and I'm going to take all of my variable terms. I'm going to put them on the right. Again, it's not that I know that left and right are the right answers here. Just pick a side. So my constants, I'm going to try to move to the right. Or I said left a second ago here. Left. On the left, I've got negative a half. On the right, I've got another constant. Move it away by doing the opposite operation. 1 minus 1 cancels out. Negative a half minus 1. This feels already like the wrong choice, but whatever. It's negative 1 1/2. I'm going to write it as negative 3 over 2. That's the same as 1 1/2, but I just like this form better. I'm going to move my variable terms with x in it, over to the right. I'm going to do that by, I've got 3x over 5 here. Can I just subtract 3x over 5? Let's see. The whole thing, throw it in a bracket? Anything I throw in a bracket is suddenly easier to deal with. That thing, this isn't, I put it in a bubble here. Subtract the negative version, or take the negative version, it cancels out. Throwing things in the bubble really seems to simplify life. So I'll do the same thing over here, negative 3x over 5. Now, what seemed to make my life easier a moment ago has stopped being easy, because now I have 4x over 2 minus 3x over 5. I gotta stop for a minute. I gotta do some common denominator business. For 5 and 2, the common denominator, we could do the ladder method or any other method you like, but it's 10. I think we've done enough of these that we can see this is 10. So I'll rewrite this over 10. 4x over 2 minus 3x over 5. I'm just doing this to simplify it into one term, but I need extra space to do it because I'm subtracting fractions with unlike denominators. So I'm going to rewrite it over 10. How did I get from 2 to 10? I multiplied by 5, so I'll do the same thing on the top. I won't write an x for multiplication though, because that's just making things worse. 2 times 5 is 10, good. 5 times 4x is 20x. On the right side, how do I get from 5 to 10? Well, times 2. So I'll do the same thing. Times 2, times 2. On the top, 5 times 2 is 10, 3x times 2 is 6x. 20x minus 6x over 10. 20 minus 6, not so tough, that's just 14x. Still over 10. That didn't magically disappear. So this is worth the same as that. I just did the subtraction off to the side. Change colors here so I know that I'm changing modes. Negative 3 over 2 is equal to 14x over 10. Okay. My x is not alone. It's being divided by 10, multiplied by 14. I know how to fix that. Multiplied by 10. Right? Cancel, cancel. That's good. Multiply by 10 over here as well. Right now I'm at 10 times negative 3 over 2. Or I could just do 10 times negative 3, which is negative 30 over 2, is equal to 14x. One more step, divide by 14. I want my x to be alone, so let's do that. Divide by 14 on the right. Everything is beautiful on the right. It's just x. On the left, I have negative 30 over 2 divided by 14. Negative 30 over 2, though, for those of you who know your times tables, that's just 15. And negative 30, I guess negative 15. If I divide that by 14, well, that's 15 fourteenths. Negative, of course. You could say that's 1 and 1 14ths. You could say 1 and 1 14th is x. 1 and 1 14th is the same as 15 over 14, because it's negative as well. But here we have it. So these ones are messy. There's lots of stuff to do, but they're still possible. And we'll do more, of course, in class, just like we always do. Seems like we're always doing math in math class. It's a pattern.